Good morning, class, and welcome to lesson 8.1.2, part D. How are periodic functions used? Objective: I will generate sine and cosine models for real-world applications. Let's jump first problem. Now, if you remember from yesterday, we left off with question 17, completing it together, and I said question 18 is something you could give it a try, and then the answers are posted at the end of the slide show. Well, maybe you have this done. If you do, great. Hopefully you've checked your work. If not, let's go through this. It says Amanda is watching her little brother Mike play on a swing set. She decides to model his distance above the ground using a sine or cosine function. She starts timing and finds that at t equaling 2 seconds, Mike is at its highest point. Let's just give that a little underline. He reaches the lowest point exactly 1.5 seconds later. Amanda estimates Mike's greatest height at 9 feet and lowest height at 1 foot. Write an equation. Well, that 1.5 seconds later, from high to low, that represents half of the period. Therefore, our period is 3 seconds. So B then equals 2 pi divided by 3, or what we could just say is 2/3 pi, or we'll just keep it as 2 pi over 3. Amplitude. Well, 9 feet, the highest point, minus 1 foot equals 8 feet from max to min. Therefore, take half of that. If you take half of that distance, you get an amplitude, or A, equaling 4. And our vertical shift. Well, if the lowest point is 1 foot off the ground and our amplitude is 4, then the midline let's erase that. Then our midline has to be the minimum plus the amplitude, which would be the same as taking the max minus the amplitude. And hopefully some of you kind of figured that out in some of the work from yesterday's lesson, which would be equal to 1 is the minimum plus 4 gives us a midline of 5. That also represents then the vertical shift, or what we call as K. Now the horizontal shift. If we use a cosine function, the cosine starts at a maximum on the y-axis. Well, she said that the highest point was at time equaling 2 seconds. Let's go with a little bit better highlighter. Therefore, that max value, if we were to make a little bit of a graph, that max value, 1, 2, 2 seconds later, we're starting at a max right there at 9 feet. We go to a minimum of 1. And we could sketch a period, but I'm trying to do this without too much of a sketch. So that represents a horizontal shift of 2 units to the right. So H equals 2. Now let's put all this together and write our equation. Remember, y equals A times the cosine of B times x minus h, double set of parentheses, plus k. So y equals A happens to be 4 times the cosine of B is 2 pi over 3 times x minus my horizontal shift of 2, double set of parentheses, vertical shift of 5. So now let's use our equation to answer parts B and C. What is Mike's height in part B? What is Mike's height when t equals 5.4 seconds? Well, I used x and y. Sorry about that. What we're really saying is let x equal 5.4 seconds. So y equals 4 times the cosine of 2 pi divided by 3, parenthesis, we go 5.4 minus 2, parenthesis, plus 5. I would recommend take all that, type it in your calculator, but make sure your calculator is in degree mode. And you type all that in, you hit equal, and you get 7.677, let's call it 0.68 feet. So after 5.4 seconds, Mike is 7.68 feet in the air. Now for part C, we have an output of 7.2. So we're going to say 7.2 equals 4 times the cosine of 2 pi over 3 times x minus 2, parenthesis, plus 5. Now start by subtracting 5 from both sides. So you have 2.2 equaling 4 times the cosine of 2 pi over 3 times x minus 2. And now divide both sides, and I'll write this one out. Let's divide both sides by 4. And 2.2 divided by 4 is 0.55, and that has to equal the cosine of 2 pi over 3 times x minus 2, parenthesis. Now at this point, you're going to take the inverse cosine of both sides. Get rid of that arrow. So if I take the inverse cosine of 0.55, that's going to have to equal 2 pi over 3 times x minus 2. And the inverse cosine of 0.55 is 0.988. So I have over here 0.988 equaling 2 pi over 3 times x minus 2. But remember, there's two solutions. We drew the unit circle in that work from yesterday. Boom. I have 0.55, and here is x being 0.55. So therefore, up here and down here, that means I have an angle. If I can get this pen to work, right there, and then I got another angle down here. I need to find both angles. So let me go back here for just a second. If I get rid of some of that in the picture. So I want to find this angle here that I just darkened in black. And then I also want to find the angle that takes me into quadrant 4. So I'm going to do that in red all the way around from the x-axis to quadrant 4. Well, the black angle is right here. I'm going to redo this. This is 0.988. So that's if you just take the inverse cosine of 0.55, you get 0.988 radians is your angle measure. And then the red one, that's going to come from taking 2 pi minus 0.988, and that comes out to be 5.30. And that's got to equal 2 pi over 3 times x minus 2. You're always going to have these two solutions within the first 2 pi radians, or one trip around the unit circle. Go through, keep solving for your x value. Here, x is going to come out to be 2.472. And over here, x comes out to be 4.528. Let's give another one a try. So now you've got a pendulum. What I'd like you to do is pause this, go through, identify all these things, and write your equation. Then come and check your equation. So go ahead, pause this. Okay, so now in part B, let's slide this back or zoom out a little bit. How far away from the wall is the pendulum in 8 seconds? So plug 8 in for t, plug all that in your calculator, and you get 68.5 centimeters away from the wall the pendulum is at 8 seconds. Now for part C, there's going to be a little bit of a twist at the end, and we'll come back and reference the graph after a few minutes. But it says, when is the time that the pendulum is the first time the pendulum is 33 centimeters away from the wall? So plug 33 in for h of t, and we want to find t. So we subtract 54 from both sides, we get a negative 21, equaling 29 sine of pi over 3 times t minus 5.5. Divide both sides by 29, and you get this negative 0.724. And now I'm going to take the inverse sine of that negative 0.724, and that's going to equal pi over 3 times t minus 5.5. Now what does that look like on the unit circle? Well, a negative 0.724. It's going to be a y-coordinate because we're dealing with sine. That's right here. And so the angle that we're looking for is this little angle coming down from the x-axis. And if I do the inverse sine of a negative 0.724, I get an angle of a negative 0.809 radians. Well, where's the other angle that would have a y-coordinate of a negative 0.724? Well, that's going to have to be in quadrant 3. So now I'm looking for this angle right here. And to find that, I have to take pi, here's pi, and you can either say plus a negative 0.724, excuse me, pi plus 0.724, or actually it's pi minus a negative 0.724, which comes out then to be pi, excuse me, we'll get this down here, pi plus 0.724 for my angle, and that happens to be 3.95. So those are your two radian measurements for the angles. And now find your t values. You're going to want to multiply both sides by 3 over pi and then add 5.5. One solution is t equaling 4.27 or 4.727. The other one is t equaling 9.27. But we have a small problem. This answer here is already more than one cycle into our sine function. Remember, the period happened to be 6 seconds. So to actually find the first place that the pendulum is 33 centimeters away from the wall, we're going to have to subtract a period from this 9.27, and we get an answer of 3.27. What does this look like on our graph? Well, let's extend this sine function. So it's going to come back up and hit a max, then come back down. That max is going to be at 1 second, 2, 3, because it takes 3 seconds to go from the lowest point to the highest point. So if it takes 3 seconds to go from the lowest point to the highest point, then if my lowest point's at 4, I'm going to have another max at 5 or at 1 second right there. So when is the actual time that the pendulum is at 33? Well, let's just say arbitrarily 33 is right there. Fairly close. Here's our first time that we're at 33. Here is the second time that we'd be at 33. That happens to be one of the solutions. That is the 4.727 right there. And then if I continue to extend that line way over here, that was the other solution that we came up with. That was the 9.27. So I needed to subtract this distance, which is 6 seconds. Subtract that from the 9.27 and I get 3.27 seconds. That's the first time that the pendulum happens to be 33 centimeters away from the wall. A lot of work, a lot of writing for this. There are more of these to practice. Here's another one that you can go through. All of the answers are going to be on the last slide of this presentation. So practice writing your equations, practice plugging a value in for t, and then practice finding those two solutions, and then use them to actually answer this question. So if you want to pause this, go through, do this particular problem, come back, I'll have an equation written up and a little bit of work for parts B and C. So now you can take a look at your answers. I solved this two different ways. I solved this using a negative cosine equation here in the black, blue, and red. So you might want to take a little bit of time to review that work. Let me grab a highlighter. So check that out. Either way, you still get the same two solutions. So wish you all the best. Check your work. Okay, there's a few more you can do and check your answers and with the answers posted at the end of these slides. Everybody have yourself a great afternoon, and the school year is winding down quickly. So let's make it a strong push through the last part of the chapter 8 and get ready for an essential skills test that would be optional for those that want to improve their grade. More details on that to follow. Thank you. Have a great day.